Hello, my good people. Welcome again to my YouTube channel or the Big Structural Hub. This is a place where you learn, build, and innovate. Today, I want to solve problem number 3, and this is a portal frame. And the question reads: analyze the portal frame shown below, and hence draw shear force and bending moment diagram, indicating all values at critical points. So this question is from a past paper and it carries 20 marks. So let's see how you can handle or solve such a question. And before I begin, I want to mention something regarding to portal frame. We have two different types of portal frame. Number one, we have symmetrical portal frame. And number two, we have unsymmetrical portal frame. So for symmetrical portal frame, this portal frame does not experience any swaying. An example of this symmetrical portal frame is this frame we are going to analyze. And number two, we have unsymmetrical portal frame. So unsymmetrical portal frame is a frame which experience swaying. So this is as unsymmetrical portal frame. So it can either sway to this side or sway to this side. So this one, it experiences swaying. A good example is this one. As you can see, it is not symmetrical. So let's see how you can solve this symmetrical portal frame. So we begin by fixed end moments. So let's start with AB. So if we can draw our beam here, so this is 5 meters, and this is A, this is B, this is fixed moment, B, A, and this is moment AB, and this is loading, which is 10 kilonewton per meter. So MF AB is equals to minus W L square over 12. So this is equal to minus 10 times L, which is 5 square over 12. So you can punch your calculator and get the answer. So negative 10 times 5 square over 12. So the answer is negative 20.83. Negative 20.83 kilonewton meter. We proceed to MFBA. So MFBA will be plus WL square over 12. So what will change is the sign. So here we'll have negative. So there's no need of repeating ourselves. Just change the sign part. So it will be plus 20.83 kilonewton meter. We proceed to BC. So this is BC. So this is 5 meters. This is UDL, 10 kilonewton per meter. MF, so this is B, this is C. So MFCB and MFBC. Again, MFBC is equals to, because this bottom frame is symmetrical, so whatever you have done here will be the same to this. So you just pick moment AB will be equal to moment BC. So take this moment and put it here, minus 20.83 kilonewton meter. And then MFCB, you pick it from here because it is symmetrical, so plus 20.83 kilonewton meter, like that. So we proceed to AD. So AD we have MF AD is equal to MF DA, and this one is 0 kilonewton meter. Because there is no loading along this span, we proceed to BE. So BE will have MF BE is equal to MF EB and is equal to 0 kilonewton meter. The same case, no loading, so it will be 0 kilonewton meter. We proceed to CF. So CF will have CF is equal to FC, which is equal to 0 kilonewton meter. So we have already calculated our fixed end moment. What follows next is the stiffness factors. So we proceed to stiffness factors. So let me rub here to create space for more calculation. Stiffness factors, which is K. So for K, let's start with joint A. So joint A. So for joint A, we will have KAD. So this is equal to, so let's say K1. K1 is equal to KAD, which is equal to, as you can see, the far end is fixed. So this one will be I over L. So the I is 1 and L is this distance, so 5. So that is K1. We go to K2. K2 will have KAB. KAB. As you can see, the farthest end is continuous. So it means the formula remains I over L. So this one will be I is 2 and L 5. So that is for joint A. We proceed to joint B. Joint B. So joint B will have K3, and this will be KBA. KBA. As you can see, the farthest end is continuous. So it means the formula remains the same, I over L. So this one will be the I is 2 and L is 5. So we proceed to KBC. K, which is K4, KBC. So KBC, as you can see, again, the farthest end is a continuous. So the formula remains the same, I over L. So this one will be I is 2 and L is 5. Like that. So that is K4. We proceed to K5, which is KBE, under joint B. So K5 is equal to KBE, which is equal to the farthest end is fixed. So again, I over L. So the I is 2 and the L is 5. We are done with joint B. We proceed to joint C. Joint C. So for joint C, we'll have K6. K6, which is KCD. KCD. So KCD, as you can see, the farthest end is continuous. So it is again I over L. So the I is 5. The I is 2 and the L is 5. We proceed to K7. K7 is equal to KCF, which is equal to, again, the farthest end is fixed. So I over L. So this one will be 5, not 1 over 5. So we are done with our modification, our stiffness factor. Now we proceed to distribution factors. So distribution factors. DF, like that. So we will start by joint D. So joint D, so we'll have distribution factor dA. So DF dA, which is equal to 0 because it is fixed, dA. We proceed to joint A. So at joint A, we will have df a d. So this one will be k ad over k ad plus k ab k ab. So KAD is 1 over 5 over 1 over 5 plus KAB 2 over 5. You punch your calculator. So 1 over 5. 1 over 5 plus 2 over 5. So the answer is a third. Like that. We proceed to K. We are under still joint A. So K, no, DF AB. So this one will be DF AB. So this one will be K AB over K AB plus K AD. So this one will be KAB 2 over 5 over 2 over 5 plus 1 over 5. So the answer is 2 over 3. The answer is 2. So equals to 2 over 3. For you to know if you are correct or wrong, our distribution factor at a common joint like this one, their total should add up to 1. For example, this plus this should give you 1. If not equal to 1, then you have made a mistake somewhere. So as you can see, our answer is very correct. We proceed to joint B. Joint B, we have DF. Joint B, we have DF BA. DF BA, this one will be K BA over K BA plus K BC plus KBE. KBE. Like that. So is equal to KBA 2 over 5. This is 2 over 5 over 2 over 5 plus KBC 2 over 5 again plus KBE. KBE is 2 over 5 again. So the answer is 2 over 5. So the answer is 1 over 3. 1 over 3. We proceed to DF. DFBC. So this one will be K BC over KBC plus KBA plus KBE, like that. So KBC is 2 over 5 over 2 over 5 plus 2 over 5 plus 2 over 5. So the answer remains a third, like that. So we proceeded to BE. So this one will be again K BE over K BE plus K BA plus K BC. So it will be 2 over 5 over 2 over 5 plus 2 over 5 plus 2 over 5. So the answer again remains 1 over 3. So you can add these three and see if they will give you 1. So 1 over 3 times 3. So it's 1. So our answer is very correct. We proceed to joint. We proceed to joint C. So joint C, will have DF CB. So this one will be K CB over KCB plus KCF. So KCB was, so KCB is 2 over 5. 2 over 5 over 2 over 5 plus KCF 1 over 5. So again, punch your calculator. 2 over 5 2 over 5 plus 1 over 5. So the answer is 2 over 3. 2 over 3. We proceed to DF. DF CF. So this one will be KCF over KCF plus KCB. So this one will be KCF is 1 over 5 over 1 over 5 plus 2 over 5. So the answer should be 1 over 3. You can add the 2 and see if the answer is equal to 1. So the answer is equal to 1. We proceed to joint F. So F will have DF FC. So this one will be 0. Again, the F EB. This one is equal to 0. Again, the F, or this one, we already have it. The FDA is equal to 0. So that is our distribution factors. So what follows next after distribution factors is this table. So I will explain in detail how to come up with such a table and get to your final moments. So the first thing to do is to draw the table, and the table has joints, members, distribution factors, and fixed end moments. So from here, going downward is your calculation. So at joints, we have joint D. This is joint D. Joint D, it has member DA. This is member DA. After joint D, we go to joint A. Joint A, we have member AD, member AD, and then AB, AB. And then we go to joint B. Joint B, it has three members. Member 1, BA, BA, then BC, and then BE, BE. And then you go to joint C. This is joint C. It has member CD, this one, and the CF, CF. You go to joint F. This is joint F, only one member, FC. Then joint E, again only one member, EB. That one. After that, we proceed to distribution factors. So we begin by member DA. So DA is this one, 0. AD, AD is a third, yes. We proceed to AB. AB is 2 over 3, here, 2 over 3. BA, BA, a third, again. BC is a third again, and the BE is again a third. CB, CB 2 over 3, CF a third, and then FC, FC is 0, and the EB is 0. We proceed to fixed end moment. So for fixed end moment, again, we have our fixed end moment here. So you just pick what corresponds to member and insert it in that table. So we begin with member DA. DA, DA, DA is 0. We put 0 there. AD is 0 again. Put 0 there. So done. We proceed to member AD. No, member AB. Member AB is negative 20.83. Also member BC, negative 20.83. So done. We proceed to member BA. Member BA is positive 80.83. 80 also member CB. Member CB, this one. So done. So the remaining are a 0, 0, 0, 0, 0, 0, 0, like that. After that, now you start balancing. We only balance member which has, no, we only balance joints which has more than one member. For example, as you can see, joint A, it has 2 members, joint B, 1, 2, 3, and joint C, 1, 2. So we will balance joint A, joint B, and joint C. So balance. To balance, it means for joint A, we have 2 members, AD and AB. So AD, fixed end moment for member AD and also AB should give you 0. For joint A to be in balance. But if not the case, then it means the joint is not in balance. Example, we have member AD, it has 0. So 0 plus minus 20.83. So the answer is negative 20.83. So it means joint A. So joint A not in balance. Now you need to balance this joint by distributing this value to each member of joint A. And how are you going to do it? So to balance, you will take positive. So take positive 20.83 and multiply it by distribution factors of each member. So if you have negative 20.83, this sign is what changes and the value remains the same. So it will change to plus. So you will take this value and distribute equally to each member by multiplying it with distribution factors. So we take 20.83 times a third, 1 over 3. So the answer is 6.94. 6.94, like that. So you will write your answer there. Again, you take 20.83 times 2 over 3. You will get 13.89, positive 13.89. That is it. We proceed to joint B. So joint B, joint B. So joint B. It means if we take BA plus BC plus BE, these are the fixed end moment, should give you 0. But if not equal to 0, it means that member is not in balance. So 20.83 plus minus 20.83 plus 0 is equal to 0. So our member is in balance. So you can distribute it by taking this 0 and multiplying it with distribution factor. It will remain 0. So 0, 0, 0, like that. We proceed to joint C. Joint C. So joint C, we have member CB. So the fixed end moment of CB plus fixed end moment of CF should give you 0. So that joint C may be or can be in balance. So let's do it. We have 20.83 plus 0 is equal to 20.83, meaning joint C not in balance. Now balance joint C. You will change this sign. So this is plus. So it will be negative 20.83. Multiply it by distribution factors of each members. By doing so, we will be balancing joint C. So we will take negative 20. So for member CB, we take negative 20.83 times the distribution factor, which is 2 over 3. You'll get your answer there. And for member CF, you take negative 20.83 times the distribution factor, which is a third. You'll get your answer there. So negative 20.83 times 2 over 3. So our answer is negative 13.89. This one. You write it there. So our answer here, put it there. CF, negative 20.83 times a third. We'll get negative 6.49. Your answer, write it there. So after doing so, this is just for an explanation, so no need of giving yourself a lot of work in your exam. So it was just for explanation. So after every balancing, the next step is to carry over. So you carry over a half of what you have balanced to the opposite member. For example, member AD. The opposite member is BA. So you take a half of 6.94 and carry it to DA. So this one will be 6.94 divided by 2. So the answer is 3.47. Here it is. You write it there. So we go to AB. So AB, the opposite member is BA. So you will take a half of AB, which is 13.89, you divide by 2. Take it to BA. So this is 6.95. As you can see, half of this is equal to 6.95. Like that. We proceed to, for this case, these are a 0, so 0 divided by half is 0, so no need for that. We proceed to CB. So CB, our CB, this is our CB. So CB, the opposite member is BC. So you take a half of CB, which is negative 13.89. Half of this to BC, which is negative 6.95. So a half of this, that member. We'll proceed to CF. The opposite member is FC. So you'll take a half of this, which is negative 6.94 to CF, which is negative 3.47. After doing so, what you need is to now get your final moment, because there is no any further balancing can proceed from there. So we go to our final moment. Our final moment is the sum of fixed end moment and the values that proceed after fixed end moment up to the last one, and then you get the total. So it's 0 plus this, you get this one. 6.94 plus 0, this one. Negative 20.83 plus 13.89, you get this one. This one plus this one plus this. This is the answer. This plus this plus this, you get that one. This is 0. 20.83 plus this is the answer. 0 plus this plus nothing, this. 0 plus nothing plus negative 3.47, negative 3.47. 0 plus nothing plus 0. No, 0 plus nothing plus nothing, 0. Nothing is also 0. So this is our final moment. For you to check if your answers are correct, we said earlier that this joint A, the final moment, the sum of final moments for each members should give you 0. So if we can check joint A, So joint A. So joint A, we have 6.94 plus minus 6.94 equals to 0. So this correct, this correct. We go to B. B, we have 27.78 minus plus minus 27.78 plus 0, 0. Correct, correct, correct. You come to this one. This is C. We have 6.94 plus minus 6.94. So 0. Correct, correct. So, and that is our final moments. So what follows next is our reaction. Before we can draw our shear force diagram, it is very important to calculate reaction for that frame. So as you can see, I have splitted this frame into simple beams, simply supported beams. So we have RA, RB1, RB2, RC. And then we have this moment 6.94, which is moment BA. So BA, BA. So BA is 27.78. This one 27.78. And then you have this one 6.94 is AB. So AB is negative 6.94 in anti-clockwise direction. And this one in clockwise direction because it is positive. And then you go to this moment again, anti-clockwise moment is moment BC, negative 27.78, this one. And then you go to this one, 6.94. This is moment CB. CB is this one. So, like that. And then, you sum moment about our points. Let's begin with summation of moment at RA is equal to 0. So, we will form an equation which is minus 5 RB. The distance from here to here is 5. Then in which direction is RB moving? Anti-clockwise, so minus, plus UDL is moving in clockwise direction, so 10 times 5, you change it to point load, times 5 over 2. The bend moment act at the center of that distance, and then plus this moment in clockwise direction, 27.78 is equal to 0. Then you solve, you'll find RB1. To get RA, you'll use the second equation, which says that summation of upward forces is equal to summation of downward forces. So the upward forces is RA plus RB1, and the downward is 10 kilonewton meter times 5. So this will be the answer. We come to summation of moment at RB2 here, RB2, so the distance from here to there is 5. RC is moving in anti-clockwise, minus 5. You come to this moment, in which direction? Anti minus, UDL, clockwise, plus, then this one plus. You'll get your RC as 20.83. Then RB2, it will be 10 times 5 minus 20.83. Reason is summation of upward forces is equal to summation of downward forces. Like that. Now we can draw our shear force diagram. So this is our beam from our frame. So as you can see, this is A here, B here, and C here. And this is the loading. So extend the line for shear force diagram like that. And then we have our reaction. At RA, we have 20.83 kilonewton. RB is RB1 plus RB2. Your answer will be 58.34. Then RC, 20.83. So we start with RA. So above the baseline is positive, below is negative. So you'll approximate 20 20.83. So let's say 20.83 is here. So you will take your calculator, 20.83 minus this UDL, you change it to point load. So minus 10 times 5. So you'll get negative 29.17. We'll come here, approximate this is negative. So 29.17. So this is an inclined line because it is a UDL like that. Let me show you my answer. So with that answer, say plus RB, which is 58. 58.34. You get 29.17. So you approximate along this line, 29.17 is positive, like that. And then you come to a UDL, so you'll take 29.17 minus 10 times 5. You'll get 20.83. So somewhere like there. So 20.83. 20.83. An inclined line again, like that. And then minus 10.83 plus RC. It's bringing you back to 0. So this is positive, minus, positive, minus. And you shade your respective figures for visibility, like that. After doing so, the next thing to do is to identify this point. Where the shear force is 0 and it is changing sign from positive to negative, call it Y. Again, identify at this side, call it Z. So you will determine this distance, X. It is the same as this distance because it is symmetrical, X. So the remaining distance will be 5 minus X. Again, this one, 5 minus X. I'm doing this because it is symmetrical. So you find the value of X because it will help you to calculate the bending moment at Y, which will be the maximum bending moment. So you can use either a similar triangle or you can directly form an equation regarding this point where shear force is 0. I'm going to use the second method, which is to forming an equation. So how do you form an equation? We know that at this point, shear force is 0. So at that point, shear force is 0. So you equate 0 to, you can either use this section or this section. Let me use this section. So it's equal to 0. And then you get the sum of all the forces up to this point, which is 0. So here we have a UDL with the distance x downward. So here we have reaction, which is RA. It is positive because it is acting in the upward direction, so it's 20.83 minus this UDL 10 times distance, which is x, like that. So we will have And 20.83 minus 10x is equal to 0, which imply x is equal to, divide both sides by 10, 2.08. So this distance is 2.08. The same to this one, 2.08. So the remaining one will be 5 minus 2.08. So 2.92. Again, this one, 2.92. Like that. So after doing so, we can now calculate our bending moment values at respective points. So begin by at A. So bending moment values. So A, at A is equal to, this is our bending moment values at A. From our table, we had negative 6.94 kilonewton meter. And then the bending moment at Y, it will be bending moment at A, which is this one, plus this area of triangle. So the answer is that one. Bending moment at B, it will be bending moment at Y, which is 14.72 minus the area of this triangle, like that. So you get negative 27.87. Bending moment at Z here, it will be the area, will be bending moment at B, which is 27.87 plus the area of this triangle. So the answer is 14.72. Then the bend moment at C, then the moment at Z plus the area of this. So negative 6.94. So our total frame was symmetrical. That's why you can see some answers are the same, like at A, and bending moment at A and at C are the same. Bending moment at Z and Y are the same. So that means our total frame was in symmetrical form. So let's now draw our bending moment diagram. To draw our bending moment diagram, we'll draw first our original total frame, as you can see. So this is the distance where our shear force was changed from positive to negative, and the value at that point was 0 or is 0. The same to this. So we'll locate our points. At A is negative 6.94. So we approximate 6.94. This is 6.94. We proceed to Y. Y is positive 14.72. 14.72. We proceed to B. B is negative 27.87. Negative 27.72. So negative 27.87, like that. We proceed to Z. That is 14.72, similar to this. So 14.72. Then the last one, 6.94. No, here, 6.94. Then we will join our points using a smooth curve, because This is a UDL. So this point, like that, to here. And then to this point. And then to here. So that is it, like that. So this is negative, negative, plus, plus, negative. And we shade our respective areas of visibility. Our question ends there. So that was all about symmetrical portal frame. If you have any question, any clarification, any addition, any subtraction, you can comment and I will be able to reply to your comments. So you can share this video. You can also comment, you can like, and also don't forget to recommend your fellow colleagues to this channel for their online study. So if you have not subscribed again, subscribe and hit that notification bell so that you may be the first person to be notified when a video is uploaded. We meet again in my next session, and thank you for your time. May God bless you.